Within this section, we're going to build our own network scanner with Python. So within the previous sections, we have used NetDiscover in order to understand what kind of devices are in the same network. But we're not going to use NetDiscover anymore, but rather we're going to create our own tool with Python. So now if you're ready, let's get started.
Hi! Within this section, we're going to build our own network scanner. And in this lecture, we're going to discuss what a network scanner is and how this actually works. So we have seen this before, right? We have worked with network attacks and network concepts in the ethical hacking part. But let me go over this once more, so maybe you skipped the previous sections, or maybe you have missed some of the concepts, so it will be good to practice once more. So suppose that you're inside of a network, you're connected to internet through a router. Maybe you're inside your home, maybe you're inside your office, or in a restaurant or a bar or a pub, anywhere in the world where you need to connect to a router, okay, a Wi-Fi access point. So there are other devices connected to that Wi-Fi access point as well, right? So they're all accessing to the internet and they are all on the same network. So once you're inside of a network with other devices, you're vulnerable to some attacks like we have seen in the previous sections, like man-in-the-middle attack. So hackers can actually do ARP spoofing and they can place themselves in the middle of the connection so they can transfer the data to their own and they can send the data to the internet and get the responses and forward it to you, and they can see all the data flowing through the internet and flowing through the network itself. And they do it with ARP spoofing. And we're going to see them, and we're going to build a new tool for ARP spoofing and man-in-the-middle in the following sections. But within this section, we're going to focus on ARP. So what is an ARP and why do we use it instead of just some malicious attacks? Of course, it has a purpose rather than being some offensive tool. It's actually used for address resolution, okay? We can pair the MAC address and the IP address, local IP address of a network. So ARP stands for Address Resolution Protocol, and we do some IP MAC pairings with the help of broadcast requests. I will tell all about it, don't worry. So we use ARP, and suppose that you're inside of a network and you're this computer right here. And you can use this broadcasting thing. You just broadcast a message to the whole network and you say who has 192.168.0.12. Okay, you're searching for a particular IP address and you just send this message to every device on network. And once this IP is found in here, this laptop says back to you, I have this 192.168.0.12 and my MAC address is this. So we can match the MAC address and IP address of this MacBook, of this laptop, of this device in a network. So you can imagine we can do this for every IP address in a network, and we can match and we can see the network map, okay? We can see every device connected to a network and we can see their IP addresses and MAC addresses and the pairing of them. Maybe you remember there is a tool called NetDiscover to do that, but we're not gonna use NetDiscover, of course. We're going to build our own ethical hacking tool in order to be able to do that. So let's stop here right now. I think you understood the logic behind what we're going to do in this section. So we're going to start building our own tool in the following lecture. Hi! Within this lecture, we're going to see how a network scanner works, and we're going to build our own tool according to that principle. And I'm running Kali Linux and my Windows 10 virtual machines at the same time right now. And you're not supposed to do that after very end of this lecture or section. So I'm going to show you one thing, then I will turn down my Windows 10, because you know running Kali Linux and the Windows 10 at the same time may consume some RAM and it may slow down your computer. And actually, after very end of this section, we're not gonna need this one, but I'm going to show you this for an example. So if you want, you may not start Windows 10 at all. So I'm going to run netdiscover --help. And if you remember, we have used this tool with range option when we deal with network scanning in the previous sections. Okay, so I'm talking about this range. So this scans a given range, and here is an example. So it scans 192.168.6 and 0/24. So what did it mean? It meant that it started with 0 and it went all way to the 255. So it didn't stop at 24. So if we had something like 6.200, it covered this IP address as well. Okay, so if you do it like this, 0/24, it means that go and search for everything. So let me clear this and let me do this for our own virtual network here. So what do I have to do? I have to say -r 10021/24. And if I hit enter, it will try every possible IP in this range. Okay, so it will start with 10.02.1 and it will go all the way up to 10.02.255. So in this case, we have a different IP address in here, 10.02.6, and the previous ones are related to the virtual machine, the router, and the router itself is the host machine in this case. So we are in a NAT network right now. Okay, and as you can see, it matched the IP addresses with the MAC addresses, like we want to do with ARPs. So netdiscover actually makes this possible. So let me go back to my Windows machine in here, and if you didn't start Windows machine, if you're just watching, it's fine too. All I'm going to do is just run ipconfig in here and see if this machine is actually the 10.10.26. Okay, so let me run ipconfig in here, and rather than ifconfig, I'm running ipconfig in Windows, remember. So as you can see, this is 10.02.6. So we managed to find this IP address, and we managed to find the MAC address of this machine as well. So we're going to write our own netdiscover and see how it's done. So right now I can actually turn down this Windows machine, and after I finish this netdiscover or network scanner program, then I will be able to open it again and test it. In order to save RAM, I'm just going to close it down. So let me go back to my Kali Linux here and hit Ctrl+C to exit out of this. Okay, now if I do this once more, then I won't see 10.02.6, as you can see, because it's not in the network anymore. So it really works it really displays the devices that are connected to our network, and it really finds the MAC address of these related devices. So we want to do the same thing with Python right now. So let me clear this and let me go back to cd opt and let me go to PyCharm, okay? And remember, we have to go into the bin and we have to start this pycharm.sh. So it will open the PyCharm for us. It's a little bit inconvenient, I know, but it's not that hard. So after it starts, all I have to do is just open a new project. I'll say create a new project from here, and if the existing project opens in your own machine, it really doesn't matter. All you can do, you can go to menu, say file and new project. And let me give it a name like my network scanner, okay? Then I can say create and it will open the project for me. So let's stop here, and within the next lecture we're going to start writing our own network scanner. Hi! Within this lecture we're going to see how a network scanner works, and we're going to build our own tool according to that principle. And I'm running Kali Linux and my Windows 10 virtual machines at the same time right now. And you're not supposed to do that after very end of this lecture or section. So I'm going to show you one thing, then I will turn down my Windows 10, because you know, running Kali Linux and the Windows 10 at the same time may consume some RAM and it may slow down your computer. And actually, after very end of this section, we're not gonna need this one, but I'm going to show you this for an example. So if you want, you may not start Windows 10 at all. So I'm going to run netdiscover -- help. And if you remember, we have used this tool with range option when we deal with network scanning in the previous sections, okay? So I'm talking about this range. So this scans a given range, and here is an example. So it scans 192.168.6 and 0/24. So what did it mean? It meant that it started with 0 and it went all way to the 255. So it didn't stop at 24. So if we had something like 6.200, it covered this IP address as well, okay? So if you do it like this, 0/24, it means that go and search for everything. So let me clear this and let me do this for our own virtual network here. So what do I have to do? I have to say -R10021/24. And if I hit enter, it will try every possible IP in this range, okay? So it will start with 10.02.1 and it will go all the way up to 10.02.255. So in this case, we have a different IP address in here, 10.02.6, and the previous ones are related to the virtual machine, the router, and the router itself is the host machine in this case. So we are in a NAT network right now, okay? And as you can see, it matched the IP addresses with the MAC addresses, like we want to do with ARPs. So netdiscover actually makes this possible. So let me go back to my Windows machine in here. And if you didn't start Windows machine, if you're just watching, it's fine too. All I'm going to do is just run ipconfig in here and see if this machine is actually the 10.10.26. Okay, so let me run ipconfig in here, and rather than ifconfig, I'm running ipconfig in Windows, remember. So as you can see, this is 10.026. So we managed to find this IP address, and we managed to find the MAC address of this machine as well. So we're going to write our own net discover and see how it's done. So right now I can actually turn down this Windows machine, and after I finish this net discover or network scanner program, then I will be able to open it again and test it. In order to save RAM, I'm just going to close it down. So let me go back to my Kali Linux here and hit Ctrl C to exit out of this. Okay, now if I do this once more, then I won't see 10.02.6 as you can see, because it's not in the network anymore. So it really works. It really displays the devices that are connected to our network, and it really finds the MAC address of these related devices. So we want to do the same thing with Python right now. So let me clear this and let me go back to cd opt and let me go to PyCharm. Okay, and remember we have to go into the bin and we have to start this pycharm.sh. So it will open the PyCharm for us. It's a little bit inconvenient, I know, but it's not that hard. So after it starts, all I have to do is just open a new project. I'll say create a new project from here, and if the existing project opens in your own machine, it really doesn't matter. All you can do, you can go to menu, say file and new project. And let me give it a name like my network scanner. Okay, then I can say create and it will open the project for me. So let's stop here, and within the next lecture we're going to start writing our own network scanner. Hi, within this lecture we're going to create our broadcast, because as you can see we have finished the first step, which was the ARP request creation. Now we have to broadcast this ARP request in order to get the device's responses within the same network. So I'm going to use KP in order to achieve this once more, and I'm going to show you another instance, another class of KP. So let me create a broadcast packet here, and in order to do this I'm going to call KP once more, but rather than ARP I'm going to use a class called ether. Okay, remember the ether, it's related to MAC addresses. Okay, and once again let me do skp.ls to see the keyword arguments that we have to give, or we may give, once we create the ether instance. So let me save this and just run this. So since now I'm running skp.ls, I will see the output of the ether class. Yeah, as you can see now we have three sources in here. One is dest, source and type. And this destination MAC field actually means that where we are going to send this packet, and the source MAC field is where is the source coming from, where is this packet coming from. And as you can see, destination MAC field has the value of FFFF for 6 times. So this FF actually means just send this to a broadcast. Okay, I mean it's going to broadcast this packet all over the network if we give this value, and it's already here. It's the default value of this dest MAC field, but sometimes it's not. It just changes according to the version of KP. Okay, so I'm going to write this FF thing manually in my code as well. But if I didn't write it, it would have turned out the same, since this is now the default value. But maybe the developers of KP will change this while you are watching this, so I'm going to write this manually in here as well. So what we are going to change is DST, the destination, and I'm going to write FF 6 times with colons, of course. And remember, this means that just broadcast this. And at this point, I think we are ready with broadcast packet as well. And now we're going to send our packet. And in order to send our packet, we need to combine these two requests into a one single request. Okay? So basically, we are trying to send this ARP request packet. Okay? Take this ARP request packet and send it to a broadcast. And we have this broadcast packet, and we can use kp.send method, okay? And I'm going to show you that method in a minute, but we have to combine these two packets first. And Scapy has a very interesting way to combine these two packets. And you won't come across this kind of usage very often, and it looks a little bit confusing because we don't see it anywhere else, but Scapy just tells us to do it this way. Just don't be intimidated by that. It's really easy actually, but it's a little bit unusual. So what do we have to do in order to combine these two packets? We have to create a combined packet variable first, okay? So you can call it whatever you want. I'm going to call it combined packet. And then you take the broadcast packet and put a slash and just do the ARP request packet later on. So we're combining this broadcast packet with ARP request packet. And this is actually related to the send method of the Scapy. And as you can see, it's very easy. You just put a slash between them, but we're not dividing them, we are combining them, so it's a little bit confusing in convention, but this is how it works, right? How do I know how it works? Of course, you have to read the documentation as I suggested before. So let me go back to documentation, and in here we have a send and receive packets method, SR method. Okay, so the function SRP talks about SRP and SR. So these two are send methods of Scapy, and we have to use SRP to send two packets at the same time. And actually you can see the slashes and the combining thing in here in the examples as well. So if you pay a little attention here, you will see that this returns us a couple of packet and answers and unanswered packets. Okay, so we can actually see the answered and unanswered packets at the same time. Of course, we are interested in the answered packets because why? Because we want to get the real devices in a real network, and they will respond to the ARP request by saying that, yeah, I have that IP and my MAC address is this, and we want to pair these MAC addresses with IP addresses. So let me try this. So I will just use this SRP thing. So I will say scapy.srp, okay, and open a parentheses, and inside that parentheses I will specify my packet to be sent. This is combined packet, and I also need to specify a timeout, which is 1, which basically means that don't worry if you don't get an answer, just continue with the process, okay? And if I don't specify this, it will get stuck once it cannot find any answers to a specific IP. In order to keep things moving, I have to specify this timeout as 1 in here. So I think we are done right now. It will just create my request packet and it will scan this IP range. Then it will broadcast my packet to all over the network in order to scan this IP range actually. Then I will just send it through using SRP methods. And as you remember, it will return us some packets. Let me just for right now print this, okay, in order to see the results, or let me just cast this to a variable called the results, then print this. Later on, we will see how to process these results and show it to the user. So let me save this all and minimize this. Let me run my netscanner.py once again. And as you can see, it finished sending 256 packets, and it says that I have received 3 packets, I got 3 answers, and the remaining packets just stayed unanswered as expected, right? So we have the results here, we have the unanswered results here as well, but we have to dig a little deeper in order to show it to the user. So let's stop here and do that in the following lecture. Hi, within this lecture we're going to go over our third step, which is processing the responses. So as we have read in the documentation, this returns us an answered list and unanswered list as a tuple. Okay, so let me try to get this as a tuple. Okay, I'm going to call this answered list and unanswered lists, and I'm going to try and print the unanswered or answered lists. We are not going to deal with unanswered list at all, but I'm going to try and print the answered list and see if we can get the result back in a neat way. Okay, so let me save this and try to run once more our mynetscanner.py. And as you can see, we don't see the results in here as a list. I think I have to cast this as a list, but at least we managed to get the answered list only. Okay, so let me try this way. Let me cast this to be a list and see if we can get the results back. So let me save this and run this code once more. So if I run this, now we see the result as a list, but I think it's a little bit complicated and ugly. Let me make this into a full screen. And as you can see, we now see the ether, the ARP, PDST, and the destination ether, the source ether, and everything inside of that list. It's a little bit complicated and our user cannot understand this easily. Actually, there are a lot of cues and important information in here to analyze that. Maybe we can just try to do a for loop in this list or do some regular expressions to get the relevant items back, but I'm not going to go over with this because Scapy has a built-in method to do that for us, and it's very easy and it's very efficient and it's very good format for us, for users to comprehend the results in a better way. So I'm going to show you how to do that. We don't have to print the list, or we don't have to cast this as a list at all. So let me delete this and let me show you how it works. All you have to do is just say answered list dot and say summary, and this method will take the all related items and show it to the user in a very good format. Okay, so all you have to do is just say that summary and it will take care of everything for us. So let us run the code once more and see how it looks like. And now, as you can see, we have a pretty good format. We see the ARP packets going to the different IPs and saying who has this IP, and it displays the responses as well. It says that I have this IP, yada yada yada. Now let me open this Windows and try it with Windows one more time in order to make sure that our NAT Discover, our network scanning tool, actually works, because now we see only the VirtualBox related items in here, the host machine and the router itself, but we don't see any other options, any other devices, because they are not in here anymore. So let me go back to Windows. Yeah, it's opened. Let me just give the password here and hit enter to open this. After it's opened and after it's connected to the NAT network, it will display the Windows as a separate device on the same network in our code as well. So wait until it's opened. Yeah, I think it's opened for me and it's connected to the internet. So let me go back here to Kali and let me give my password once more. And now we are ready to test this. If we do python mynetscanner.py once more, then you will see that 10026 is here with this MAC address. Now we are done with our MyNet scanner. We finished our ethical hacking tool. Now we can leave it in here as well, but I'm going to beautify this code, reformat this code once more, and I'm going to make sure that it works with Python 3 as well. So let's stop here, and within the next lecture we're going to do those. Hi! Within this lecture we're going to reformat our code on my network scanner in here. And what do I have to do, what do I want to do actually, is to take this IP range as an input from the user, also make all of this into functions so that our code will be much more prettier, much more neater. And I believe at this point you can do it on your own. Okay, you can take this as an input from terminal from the user. So you have to add a -i or -ip range in here. So I suggest you pause the video and get the same exact result in here with the supply of the IP range, of course. Now I turned down the window so it won't show up in here, but it really doesn't matter. I know my network scanner actually works. So pause the video and try to do it on your own. I hope you managed to get it. So let me do it one step at a time. So first I'm going to define a function called scanMyNetwork, and within this function I will just take everything in here and hit tab to run all of this code inside of my function. And of course I'm going to take IP as an input and supply it in here as PDST. Because why? Because we're going to take IP from the user as an input. So the scanMyNetwork will be my main function, but also I'm going to have to take the input from the user using the opt-parse or arc-parse module that we have used before. So I'm going to create another function for that. And remember, first we have to import the related library in here, which is opt-parse. And down here I'm going to create a new function called getUserInput, as we did before. And inside of that function, first I have to create an opt-parse object, which is parse object, okay? And remember, you have to say opt-parse.optionParser and put parentheses at the end. So now we created our own instance. Now let me work with that instance. Say parseObject.addOption. And we're going to work with only one option here because we're going to take the IP range only. So let me give the first argument as -i, and this will take the IP Of course, you can say something like IP range with 2 dashes, okay, or IP address, whatever you want at this point. And let me do comma and supply help function here as well. So this is to get the IP address or something, or you can just say enter IP address. You can be more explicit here if you want. I'm going to make it short. And then remember what? Remember, we have to get the arguments of that parse object. All I have to say is just parse object dot parse arguments. Okay, so if I do that, it will return to me a tuple, as you may remember. And within that tuple, I will have my arguments and my returned inputs. Okay, so I will say user input and arguments. And I will work with user input. First, we have to check if it exists. So we're going to say if user input is actually true. And in order to do that, remember, we say if not, user input and dot. I believe we forgot to specify the destination. Okay, so let me do it first, which is a great mistake in here. So we have to specify a destination variable. Okay, and let me call this like IP address or something. But let me do it with underscore in order not to confuse with this IP address in left here. Okay, so it's going to save this into IP address, so I can say IP underscore address in here. Okay, so if it means that if not user input dot IP address, and it means that if it doesn't exist, so it means that either user didn't give an IP address or either there has to be some sort of error in here. So I will say print enter an IP address. Okay, so of course you can do it with if user input dot IP address. It means that if it is true, then do this, else do this. But if you say if not, it means that there is an error and I want to do this. So this is an alternative way of what we have done in the previous section. So if there is an error, it will run this, and if there isn't any error, it will return this user input dot IP address. Okay, and then we can use this get user input function in order to get the IP and supply it to the scan my network function in here. So let me create a variable called user IP address in here. Okay, so user underscore IP underscore address. And how do we get that? We get that from get user input, and since this will return me the user input, not the IP address itself, I will say scan my network, and inside here I have to say user IP address dot IP underscore address. Okay, so I have tried to be alternative as much as I can in here. As you can see, maybe you have written some code different than mine here, but it really doesn't matter as long as it works. So maybe you used if rather than if not in here. Maybe you used a user IP address in your own way. It really doesn't matter. So let me try this without giving any inputs, and let's see if we get an error back. As you can see, it says that enter IP address. So let me give it an IP address in here, 10.2.1/24, and if I hit enter, it will just scan this IP range and get the results back to me. So now we are done here. Okay, if you just try this with no IP address, again it will say an error, option requires an argument, then everything works fine. Now we are okay and we can stop here, and within the next lecture we're going to just see if this is compatible with Python 3 as well. Hi! Within this lecture we're going to see if these codes are actually compatible with Python 3. So let me run this Python mynetscanner.py with 10.02.1/24. It will run and scan the whole network. And if I do this with Python 3, you will see that it works out fine, pretty well as well. So it is fully compatible, but maybe you will have to install the scapy Python 3 version. So all you have to do is just say pip3 install scapy. Okay, so this is fully compatible, and let's keep it short and stop here. Within the next lecture we're going to write our own ARP spoofer.
Hi, now you have completed Network Scanner tool with learning some new concepts like ARP requests, scapy, processing responses, and some more additional features as well. Maybe right now you can be thinking that how can I write my own man-in-the-middle tool since now I can gather the information from the devices on the same NAT network. That's what we're going to learn within the next section.